right? So when it's that direction, so we know that this is your moment about what? Moment about y. So moment about y, this will be compression. This side will be tensile, right? So when that's the case, element A, right? Element A will be negative compression. And element B, you cannot see in this diagram, but it's going to be tensile. Okay, I will tell you why. If I were to zoom in over here, right, element B, right, is on the right-hand side of the centroid. Okay, so if I'm going to exaggerate element B, okay, so element B, okay, I have to wipe this off. I have no choice. I'm going to draw this again. Of a centroid, green, right? Element B is this side. Element B. Over here is our element B. Okay, so it's on the right-hand side. So it's going to be what? Tensile. Okay. Okay, so from here, anything else to analyze at this view? The answer is nothing else to analyze. Okay. Then we do another view. Okay. Anyone, any question so far? Anyone online, any question? No, no one have question. Good. Okpara, you okay? Okpara, can you hear me?
Yes, yeah, I'm still going to review the notes later. And I
Yeah,
don't
yeah, okay.
listen.
If not, come and see me. I'll be here until 4 o'clock today, okay?
Okay.
Okay. Okay, so nothing else to analyze. We are going to do another direction. Okay, now we are going to look at YZ plane. Okay. So this is our Y, this is our Z, and this is rotation about X. Okay, so I'm going to draw that view again. Okay, so I'll add some additional features. Okay, and we have this, right? Then we have our element A. Then we have our element B.
Actually, Eugene.
Oh no, yes.
Do you mind actually just going through that moment calculation again? I'm
The
trying
what?
to the moment calculation. I'm trying to
So the
understand.
moment calculation in the previous one is 16 is because you have 2 8s, right?
Right.
Then 0.5 plus by 0.1 is this distance over here.
Oh, okay.
Okay.
All right, thanks.
You're most welcome, Sunshine. Okay, then from here, we are going to construct our centroid. You can see how important the centroid now is. Okay, so this is our centroid. Okay, then we put in our forces. So you have 100 kilonewton over here, right? Then you have 25. Then you have 2 crosses. You have your 8 kilonewton. So don't analyze the dots and the what? The crosses. Okay. So now you see over here, you have to be really, really careful. I'm going to do the difficult part first. I'm going to take the moment in the X direction first. Okay. So I'm going to call coming down as positive moment in the X direction. Okay. So the 25 kilonewton, the force is perpendicular to the centroid. So this is our distance. From here to the element, this is equal to 0.5. Okay, so this is multiplied by 0.5. Then plus the 100 kilonewton now is what? Parallel to the what? To the centroid. So the distance you take is not to the element, but you take to the what?
Centroid.
There you go, you know. Okay, you don't need a software that is $250,000 to do this. Okay, they should hire you and pay you $250,000. Okay, so now it's also the same direction. So it's 100 times 10 to the power 3. Now, what is that distance? Okay, so now we have to look at our table now. Okay, we have to, I'll let you guys copy first. I don't know. Yeah, I don't know. We have to see. Okay, I don't want to guess. I really don't know. So we come back to the table. Okay, you can be right. Okay, so D, right? D is the distance that we need to know. Then we divide by half. So D is 205. Okay, 205. So this is equal to 0.205 divided by 2. Okay, why divide by 2? Because the whole distance from here to here is equal to 0.205 meter. Okay, so this will be equal to 25 power of 3 times by 0.5 plus the 100 power of 3 times by 0.205 divided by 2 is equal to 22750. Okay, Newton meter. And the direction is going is this way. Let me do it again. 23 power 3 times by 0.5 plus 100 power 3 times by 0.205 divided by 2. 22750. Okay. So now we know that this is moment about x. Okay. And we know that this is compression. This is going to be tensile. Okay. So when that's the case, right, we know that element A is going to be positive. It's going to be in tensile mode. And we know that element B is equal to 0 because it's at the centroid. Okay, we know because it's at its what? Centroid. Yes or no? Okay. So this is the difficult part. Okay, this is the difficult part. The rest is easy. Then we know that positive is going towards the left, right? So Vy is equal to 25 times 10 to the power 3 Newton. Okay. Now then you ask Eugene, what are the stresses acting on shear stress acting on Vy? So if you look at the shear stress acting on Vy, okay, so we know that the shear stress is equal to Vy over Ixx Qx divided by T. Okay, so we are going to take that image again, the one over here. And I'm going to copy and paste. Okay, so Vy is coming in this direction now. Okay, so this is our Vy. Yeah. Yeah, wrong color. Come on, Eugene. Okay, so this is our Vy. So it's going to be what? Thin wall analysis, yes or no? So if thin wall analysis, it's a white flange, we are going to construct the shear flow. Okay, so this is your element A. Wrong. Yeah, it's okay. This is your element B, right? So what we can say about this? So element A, based on the shear, is not equal to 0, and element B is going to be your what? Tau max. Okay, nothing is 0. Okay. So now, are we short of anything? I don't think we are short of anything now. We have everything now. So we have our axial load, our Vx, our moment, our Mx, and our Fy, everything. We have everything now. Okay. So now it's time to plug in our favorite formulas. Okay. Now it's time to plug in our what? Favorite formula. So now is we go back to, now you know your moments, you know your axial load, you know your shear force. Now just plug in formula. Okay, so we're going to plug. So I'm going to do two. I'm going to do both element A and we are going to do element B. Okay. Important things are all these remarks that you have done. You have remark over here. All these remarks that you have made are very, very important. Okay, all these remarks that I'm highlighting now are very important. Not this one, sorry. Right, all these remarks that we make are very, very important for now. Okay. Okay, so now we are going to do, as I said, we're going to do both element A and element B. Okay, so I'm going to copy this. Now, I'm copying things. I will say this. The person in your company, if your company is a structure analysis company, okay, the person that has to be very sure about this, I mean, when I say very sure, is have confidence is this, are the principal engineers. Okay, the principal engineers have to be crystal clear on how the forces, moment, torque are acting. Okay, so as junior engineer, we carry out the what? Calculation, and he will check. Okay, and eventually, I believe, I'm a sole believer over here, that all of you one day will become a principal engineer. Are we clear? That is the purpose why I teach this, okay? Because I'm hopeful for you guys, okay? I don't want you guys to just remain as a junior engineer, okay? Then I need another diagram. Okay. So the information that we need now are geometries now, okay? So we know D, so we are going to use over here. Okay, we're going to use 41 point. Come on. Okay, we're going to use this data over here. Okay, because this has been chosen. Depth, this is 0.205, right? Our flange TF is 11.8. Our T, the web thickness is 7.24. Our BF is 166 or 0.166. Then our IXX is equal to 40.8. Our IYY is equal to 9.03. And then our area is equal to 5320 times 10 to the power minus 6 meters squared. Okay, we have everything now. Okay, so these are the information that are needed from this table. Okay. So we know that this is our element, Element A. Over here is element B, and the distance from here to here is 75 millimeters. Okay, so that